Hey guys, Mr. Mias is here, and in this video we're almost done with AB calculus. So I'd like to do some review of some basic integration formulas, talk about integration in terms of what you're going to need to be doing for the AP exam. So if you're in Essentials of Calculus, you'll see that there is a list of all the integration formulas that you're expected to know on page 211. Go and take a look at that. If you're not in Essentials of Calculus, make sure you look up an integration formula sheet there. I mean, it looks pretty overwhelming. There are a lot of formulas, but if you know how to use each formula, then and you work on memorizing the formulas by spending just a little time each day to remember, to look, maybe flashcards, then you're going to be fine on the actual day of the AP exam if you're taking this for an AP class. But for integration, memorization is not going to be enough. You can't just memorize everything and do integration. Integration is not as straightforward as differentiation is. You know, with different derivatives, you can just follow the recipe. It just goes what it goes. But with integration, you're going to have to distinguish a lot from lookalikes. They might look similar, but you're going to need to make sure you pick the right integration technique. So those are what gets integration a little tricky. So a couple things that you can do to make sure that you have success when you do integrals. All right. First thing is memorization of the formulas. The better you are at memorizing what you're going to do, the better you are at going to be able to understand and when to use them. Second is you're going to need to recognize which formula is given in any given problem. So sometimes they'll pop out at you, but you're just going to have to recognize them, and that takes experience and practice. So the other thing that is successful, number 3 here, a successful thing, something that will make you successful in integration, sorry, I'm tongue-tied here, is the ability to use algebraic techniques to simplify or to make the integration look the way that you want it to look, to apply some of the integration formulas. So sometimes just having good algebra skills is going to help you on this. And the last thing is just practice. Okay, lots of practice on integration is just going to make you better at doing it, because you're going to recognize some of the ones that look different, and you're going to recognize some of the formulas just by practicing. So from here on out, when you're getting ready for that AP exam, you're really going to just want to practice integration as much as possible, practice differentiation, because practice, all right? So here we go. Let's take a look at some examples of ones that might look similar, but are actually different integration problems. All right, so I've got, let's see if my thing's going to work here. Okay, so I'm going to integrate these 4 lookalike integrals. And they have similar appearances, but they are very different. So this one is dx over 1 plus x squared. Well, this one is a 1. It's got a number on top. So anytime you see a 1 plus x squared on the bottom, or something plus x squared, and has a number on it, like a constant on the top, this is going to be an arctan type. Okay? So this is really the integral of 1 over 1 plus x squared dx, which is arctan plus c. Now notice b looks very similar, except it doesn't have a square. So it doesn't have a square. It's not an arctan type. This is an ln type. All right, this is 1 over 1 plus x dx. And 1 over 1 plus x, since x does not have a power in it, this is how we know it's going to be ln. So this is ln of 1 plus x plus c. Now x, notice there's an x in the top now. So it's not arctan, but it's got to be something else because it has an x in here. So whenever you have x in here and it's a smaller power than what's down here by 1, it's probably going to be a reverse chain rule. So here u is 1 plus x squared. U prime is 2x. Well, that's good. So what we need on top here, we need a 2 here and a 1/2 here so that we can have a chain there, right? So really we have 1 over 1 plus x squared where this part is u, right? We're really dealing with 1 over u here. Okay, 1 over u is an ln. So we're going to have 1/2 ln of whatever this u was, 1 plus x squared, plus c. And that came from the reverse chain rule. All right, and the last one here is 1 over 1 plus x quantity squared. Whenever you have a quantity squared, you're going to change this to 1 plus x to the negative 2 power. All right, that's a quantity squared. So then we're going to do a reverse chain, not reverse chain rule, sorry, we're going to do just a power rule, a simple power rule. Okay, so we're going to simple power rule it, and we're going to have 1 plus x to the negative 1 divided by negative 1 plus c. Okay, and that's it. So notice they did look a lot alike, but they were very different in each one based on what was in the numerator. Let's take a look at a few more that might look similar to those. All right, so we've got dx over x ln x. Oops. So this is really 1 over x times 1 over ln x dx. So whenever we see an ln, okay, whenever we see an ln, and this is another rule that I mentioned in one of my previous videos, is that whenever we see an ln in our integral, at least for AB calculus, we're going to think that this is a reverse chain rule. All right, so we're going to try a reverse chain rule first, which usually the u is going to be ln x, and then we're going to u prime that, and that's 1 over x. So there's our hook. Okay, so we're dealing with a 1 over u type, and a 1 over u type is going to give me an ln as my answer. So my answer here is going to be ln of whatever that u was, ln x plus c. Okay, let's take a look at this one here. So here we've got a very similar thing, 1 over x times ln x. This time our u here is still going to be ln x. So we're really looking at the integral of u, and that's the integral of u is u squared over 2. So u is ln x squared over 2 plus c. All right, so again, it really is about thinking about where the ln is here, whether it's in the denominator or the numerator, and depending upon that, it changes the way we're going to approach this problem. So here are a couple of simple algebraic techniques that you're going to use to fit integrals into the forms in which appear in basic integration formulas. You're going to either need multiplication, where you expand things. You're going to do term by term, which is dividing by a monomial. So anytime you see a monomial in the denominator, you're going to split that up by the polynomial that's in the numerator. If the degree of the numerator is bigger than the degree of the denominator, or possibly the same as, then you're going to use long division. And then, of course, separating the numerator and the, splitting up numerators will also work. So more complicated and little harder to see techniques, I'll show you in the next video in 9.7, some of those little harder ones there. But let's take a look at some of these. All right. So in this one, we've got an e. So this one, usually we'd say that, we might first try this, but u prime is going to be 2e to the 2x, and I don't have another one in there. Even if I did this, I don't have another one to make my hook. So normally when I see a squared, it's a little easier just to FOIL this sucker out. So I would just FOIL this guy out. E to the 2x minus 2 times e to the 2x minus 2. Just FOIL it out. All right, which is going to be e to the 4x minus 4e to the 2x plus 4. And then we can just integrate each of those separately. So we're going to have 1/4 e to the 4x minus 4/2, which is 2 e to the 2x plus 4x plus c. Okay? All right, let's look at 4. Again, so you know what I'm going to do for this one first? I'm going to change these to their fractional powers. And what do I know here? When I have a monomial, the monomial I'm going to split into all three parts here. All right, so really I'm going to have x over x to the 1/2, which is going to give me x to the 1/2, minus 2x to the 1/2 over x to the 1/2, which is just 2, plus 1 over x to the 1/2 is x to the negative 1/2 dx. And now I'm going to use a power rule for each of these. 3/2 over 3/2, which is going to give me 2/3, minus 2x, plus x to the 1/2 over 1/2, which is going to give me a 2, plus c. Okay, there you go for that one. Is that the last one on my page? Yep, let's take a look at some more here. All right, I got a ton of these guys. Number 5. All right, so now in this one here, I'm getting up closer to the screen. So this one, they're the same. So when they're the same, I can do a few things. I could try to factor out the bottom where I have x and x plus 1, but that's not really going to help me much. So usually when they're the same power, when the degree is the same power and they're both polynomials, or one is bigger than the top is bigger than the bottom, I'm going to use long division. So I'm going to long division this bad boy. So I'm going to have x squared plus x and x squared minus x minus 1. Okay, so that's 1. Changes that. Cancels all of that. Well, this is actually negative 2x minus 1. And that's all I can do. So this is going to be 1 minus negative 2x, negative 2x minus 1. So this is 1 plus negative 2x minus 1 over x squared plus x dx. Now, notice here, if u is the bottom, what's u prime? 2x plus 1, which is almost what I have there. I think if I factored out a negative, that would be nice. So I'll factor out a negative, and it does. It actually turns out to be exactly what I have up here for a hook. So this is really a 1 over u type, right? This is really a 1 over u type, which is an ln. So we're going to end up with x minus, the hook stays, the hook is the hook, goes away, ln of x squared plus x plus c. All right, so that's a long division one. What about this one? This one, what are we going to do here? Well, this is not really a monomial, but I think because this is all one thing, I can split it up into each of these guys. So I'm going to have 3 over square root of 1 minus x squared, because that looks kind of like an arc sine to me, minus x over square root of 1 minus x squared. And you know what? This is an arc sine. What I need to do, though, is I need to get rid of that 3. So I'm going to just bring it out. And then I'm going to say minus, let's go ahead and do this. Let's bring this up to the top as a negative 1/2. Okay, so what's this part? If I say this is u, then u prime is going to be negative 2x. Oh, we almost have that. We have a negative x. So what do we need? We need a 2. So I'm going to go ahead and put a 2 right there to give me a hook, and then a 1/2 out here. And then I'm going to go ahead and get this bad boy of an answer here. So I'm going to have 3 arc sine of x. That works out easy. Plus 1/2. This is going to be basically u to the negative 1/2. So I'm going to add 1. I'm going to have 1 minus x squared to the 1/2 divided by 1/2 plus c. These 1/2s are going to cancel. All right, so there we go with this one. So again, you see that there's some algebra I have to do here to get it in the forms that I want. All right, but I'm basically doing the same types of things that we've been doing the last few weeks with these problems. Okay, so a couple of things here. You can separate, when you have a monomial in the bottom, you can separate it into the top, but you cannot do it backwards. You cannot do 1 over x squared and 1 plus x. That is not legal. That is not legal algebra. Don't do it. Okay. Last couple examples. I know this is a long video, folks, but I've got a lot to talk about. And, you know, lots to talk about is important. Okay. But these are the last two. I promise. I promise. I'm whispering promise, but I really do promise. This is it. Okay. So, let's see. What do we got here? Ooh, this is juicy. What do we got? Oh, goodness. So we've got an E and a sign and all kinds of things going on. Okay, anytime I've got an E with a stuff here. I think that stuff is what my U is going to be. So that stuff is if U is cosine 2x, then U prime is negative 2 sine 2x. Well, the good news is I have sine 2x. It's right here. Bam. What do I need to finish out this reverse chain? I need a negative 2 here and a negative 1/2 out there. So I really have an e to the u type. And we know the antiderivative of e to the u is e to the u. So e to the cosine 2x plus c. That's it. Oh, that's it. Bam. That's all there is to that, okay? So it was an e to the u type. Let's take a look at this one. Now this is tricky. Anytime I see a square and something that's like a square, I'm thinking arc something. Arc cosine, arc tangent, arc, well, in fact, x squared plus 3, that's an arc tangent. I think this is going to be u. I think u is going to be tan, which makes u prime, the derivative of tangent is secant squared. Bam, look at that. That's already there. There's our hook. All right, that's our hook. And so this is an arctan type. Arctan type. All right, and in this case, the arctangent, u is tan, and a is 3. So my answer for this one's going to be 1 over a arctan of u over a, tangent x over 3, plus c. Boom. All right. So there are some examples of just kind of doing all kinds of integration formulas, integration techniques, and again, lots of practice, right? We're at the point now that we're just trying to get all these things wrapped up and put it together. Good luck, all you Myosis Mathies out there. Hopefully you can get this stuff and practice your integration, and you're going to do great on the AP exam. All right? Catch you guys later.